we think of them as these white things moving through space, but their material is very dirty on a level that, how reflective is a comet?
Well, it's difficult to say because you don't always see, most of the time you don't even detect the nucleus or the rocky part of the comet. You just see the tail. Okay. But asteroids, for example, like asteroids typically have albedo is the word we use in science, but that's how reflective they are. So albedo is between something like 0.04 to 0.1, which is like 10-ish%.
That's black.
Yes.
That's black.
Okay.
Yeah, albedo from between 0 and 1. If it's 1, it's like a mirror.
Right.
If I remember, the moon is about 7% albedo.
Okay.
And what is Pluto?
So there are parts of Pluto, like there's a glacier of nitrogen, or nitrogen ice actually, and that has an albedo upwards of like 90%.
Oh, wow.
So it's very reflective.
So it'd be a bright spot if you look at it.
Oh, you know, I read an article once that was talking about another reason why Pluto isn't a planet is because it reflects so much that it makes it look much bigger than it actually is.
Well, initially, I think that would have thrown off our measurements.
Right.
But now we got up and close and personal.
Yeah, well, now, we've been there now.
We've been there now.
We've been there now. So,
been there, done that.
Yeah.
So what's in the future of what you're up to?
So the Rubin Observatory is the most exciting thing, but it should be finding, upwards of tens per year interstellar objects.
Yeah, but this will be serendipitous. You can't say, go look at this object or look here and discover an object. You're waiting for the data to come to you.
Through you or to you.
But also Rubin should better characterize the orbits of all of the known small bodies in the solar system and find a bunch of much smaller ones. So given that we have kind of just hit the tip of the iceberg in terms of finding these dark comets, I would bet that we're going to find many, many more dark comets and subtle non-gravitational accelerations.
Right.
So that could kind of revolutionize how we think of even comets and asteroids.
All right, cool.
Wow. Look at you.
Cool. What's especially delightful to learn is that you are entering a field right when an important telescope that feeds that field will be coming online.
Yes.
And
you're going to have so much data.
Oh, yeah. In fact, tell them how much data is coming off of Rubin telescope.
Yeah, it's a huge amount. It's like...
Can you be quantitative, please? Tell Chuck how much huge...
I just don't want to say it wrong.
Good.
Because I don't know.
Yes, not only knowing what you don't know, it's knowing if you don't think you know something, then,